Good afternoon, everyone. So this talk is about what things that might go wrong when you program a smart contract. So I gave another talk earlier today, which was kind of introduction level talk to Solidity and how to start writing smart contracts. And then they asked me to give something a bit more advanced. And then kind of thinking, what should be the next step for someone who just entered smart contract? What is the next thing this guy should know? So generally people say, I don't know, they ask me to talk maybe about how to integrate with oracles, stuff like that. But my view is that after mastering the basic of Solidity, the first thing you should know is that writing smart contracts, so it's very risky. And after you master the basics and after you know what you do know and don't know, so having this fear in mind should eventually also affect how you work, both the security level, the DevOps security level you do, but also designing, testing, and other the speed development of what you will do in your Solidity career. This title, Welcome to the Future, is from some famous tweet, probably around 3 or 4 years ago, where 2 lines of code fix. So before the fix, actually triggered over $160 million of funds loss, where the funds were not even stolen, they are just stuck forever on Ethereum now. That's how the future, or a future with smart contracts, will look like, or at least it looks like it now. Tons of bugs, projects are being hacked more than one time, tens of millions of dollars. It easily cost already billions already in hacks and bugs and thefts and pyramids. So why there are so many smart contract hacks and bugs? So the real answer is that there are not that many bugs, right? I mean, every software has bugs. The only thing here is that bugs cost a lot of money. Everything is open source, so everyone can see the bug. Actually, the contracts themselves, in terms of size, maybe even complexity, right? So they are not as big as Linux kernel or whatever. So it is possible, it is possible to grab these bugs in human mind, just to read contracts, and with enough efforts also to exploit them. But on top of that, and this is how the original, even these days, most bugs came to life, is that this is still very early stage ecosystem. A lot of startups have to move quickly, and they have to move quickly, because of funding is limited, but also maybe because tomorrow Bitcoin will be gone, right? And we need to ride the hype. You need to move quickly. If you need to move quickly, you have less time to test. And this is how standard bugs that, simple test could have catch. So you simply don't catch them if you move too quickly. But then on top of that, there are specific, like Ethereum or blockchain related bugs that simple testings will have very hard time to track. And these are kind of the next generation bugs, which are specific to blockchains and smart contract. So things like the DAO hack or attack vectors in general, things that you need to kind of think maybe like a hacker to see if there are bugs there. It's not something tests will solve. Having maybe more security experts in your team, security consultants, auditors might solve it. And then, since like a year or 2 ago, with the boom of DeFi summer, and after that, So yeah, you have DeFi integration bugs, which in the real world, I know when you try to integrate with some system, you always have these bugs, which is actually no one fault, just that one system didn't really understand how the other system work. The spec might have not been perfectly clear. So now with DeFi, you have systems with billions of dollars that integrate with each other. Each have some understanding on how the other system works, and sometimes understanding is not perfect. And yeah, when you have big integrations, it's really hard to even understand how the entire full system will work, to grasp the complexity there. So yeah, these are there's a long line of work with DeFi integration bugs. And of course, with DeFi, also something which is kind of unique to blockchain is a flash loan attacks, which actually allows you once some bug or once an exploit exists in the platform, you can often take advantage of it without having any capital of your own. Which is something which is very untypical, like in the traditional world. If you want to do price manipulations, you have to have billions of dollars. Yeah, and finally, things which are still not very much discussed, but actually now this is what I spend most of my times on, is so-called financial bugs or financial risks, where the system actually operates as intended. But basically under the hood, it's an obvious pyramid that eventually collapse. So Luna might be an example for that. Also, you can argue, I don't know, maybe they had best intentions in heart, but there are also now other lending markets which just operate carelessly and trigger a lot of money loss. So yeah, let's start with the basic simple bugs like we have in any software. So this is one of the famous first bugs around 2016 or 17. Back then, the main use case of Ethereum was to make your own ERC20 token. So this is actually done by some Israeli project called EtherCamp, I think. So yeah, they programmed ERC20 smart contract, and so now here, instead of having this plus to the left hand of the equal sign, they reversed it. These days, part of the conclusions and like basically every such bug that makes such impact. So now maybe the compiler will actually warn you about that. Back then things were still at very early stage. So yeah, they deployed the smart contract, had a net value there of around $1 million, which back in 2016 was considered a lot. But yeah, the token became unusable because anyone could steal the funds here just because they had this syntax error in the code. So syntax error, but this is perfectly valid code, of course. And of course, also once they see it, they cannot change it. It's already on the blockchain. So technically there, I think they just redeployed it, but of course in the meantime there was some trading there, money was stolen, etc. So this is something basic testing, should have caught. You see that the balances would not have increased. So yeah, so these are the basic bugs. And of course there, testing is supposed to save you, but then comes bugs that standard testings will not catch, especially if you don't know what to test. So classic and something which is quite easy to understand is access control bugs. So in Solidity and smart contracts, you have functions that can be called either only internally or by anyone. So here, this is a code that was deployed by Bancor. Bancor is a decentralized exchange or have some decentralized exchange functionality. Part of the functionality of course, if you're on exchange, you want to move tokens from one place to another. But here, basically, tokens that reside in the Bancor smart contract, or technically that people who gave allowance there. So anyone could call this transfer function because it's public, without any validation that only some operator should call it, and get your money. And it's not even only money that is in Bancor, but was somewhat all of the money that users that kind of ever use Bancor. This was, of course, for a new version, so the impact was pretty limited. Also here, Bancor caught it on time because someone reported it and actually kind of saved the funds by stealing the money from themselves. There were some side effects there because someone tried to duplicate. Once you see in the blockchain that money just goes into someone's wallet without any investment from their side, so people try to duplicate it. So some tens of thousands of dollars got lost because people were actually reproduced these operations, but overall it was caught on time. Something which is much more dramatic, it's the parity multisig hack. Around 2017. Multisig is allegedly a secure way to hold your crypto because it requires signatures for multiple users in order to make a transaction. So from DevOps point of view, it's much more secure. Even if one key is compromised, the funds are still safe. But of course, it requires to have a smart contract that will actually hold it. So Parity made very popular smart contract framework, also a complete application with nice user interface and everything. And yes, somehow all of it was relied on one deployed library, which all the wallets used. And then someone found out that they can actually kill the logic there. So it's, if you guys know what suicide mean or self-destruct in smart contracts, so you can just kill the smart contract. Now it no longer executes any logic, so it just killed all the multisig wallets. He actually never made profit out of it. He even bothered to kind of brag on it, open an issue in their GitHub saying they killed the wallets accidentally. Of course, it was not accidental. And over $160 million back then were lost. Actually, these days it even was much more. So there's money, now stuck in these contracts which are dead forever. And the only fix there was to make this function internal, which of course they did, after the fact. But also, of course, since then no one is using them. Also, they kind of voluntarily decided not to do multisigs anymore because it was the second hack actually for the multisig. So again, something which is not very easy to test. If now you have like access control in mind, so maybe we'll make special tests for that. Another type of bugs is bugs that stem from how the blockchain work. Like the previous bugs were kind of abstracted away from the blockchain. It was just bad logic. But there are some stuff that smart contract cannot do. And the classic things there is to run unbounded logic in a loop. So in the early days of Ethereum, this actually happened multiple times. So we have some lottery or some pyramid or whatever contract that just distribute money to some winners. But it sends the reward, to multiple destination addresses. And here there are actually few issues. One of them Yeah, so one of them is that now you have to, if you have too many users, it will just stack, because no matter how many gas you can put, so Ethereum has some kind of hard limit to the gas. So at certain point you could just never execute it, no matter how much you are willing to pay for gas. And then all the bounties, are locked in the smart contract forever. Also there are some patterns where, it's considered not okay to send ETH to someone in a loop, because the destination, the receiver can actually make the entire operation to fail. So these are the kind of things that, access control, especially these patterns, that over time, it's not even over time, but like very initially at early stage, even if you look at the Solidity manual, people warned about it. Of course, new developers didn't know it, but over time, best practices are learned, and these kind of basic bugs become more rare. But then you have new bugs, or it's and again, like here, like the distinct, like if you really want to differ between a bug or an attack vector, right? So it's really not that clear. So once in a while, new attack vectors are emerging. This is one, of course, is very old, but unlike the bugs here, where people kind of warned about them before they happened and tried to warn developers, and it was only a matter of dev education, etc. So here the DAO hack, it was actually a manifestation of like completely new attack vector that no one actually thought about it before. So yeah, it was one of the big, I think probably the first big scale hack on Ethereum. Actually, led to a lot of like arguments and discussions, because eventually it was reverted by the chain itself. But yeah, it gave rise to re-entry attack, which these days it's kind of classic textbook attack that everyone knows. But again, before someone actually did it, very few thought about it and were aware of it. So yeah, so basically what is re-entry attack? The thing is that in ETH, in smart contract, when you send Ether, or when you send ETH to someone, you actually potentially trigger another smart contract invocation. But in the more broader sense, when you make calls sometimes to address you don't know, and you have no idea what it will do, so you kind of have to assume the worst case. And then, okay, so here in this float withdraw function, so first we read the user balance, right? Then we send him the ETH, and then we reset the balance. Now this is potentially can be a smart contract call, and this smart contract can potentially call withdraw function again. All right, so what we end up with is that this ETH will be sent twice, but the balance will be reset only once in the end. And of course, this validation that you actually have balance will not be called on the second time. And of course, you can call it more than twice. And of course, people are calling it more than twice. And yeah, and this is still, so until DeFi, okay, so this just became like kind of a bad practice, and people knew that they had to avoid it. After DeFi became popular, it's not even that easy to understand if you need to be concerned of it, and even how to mitigate it. So still to these days, it's the source of many hacks and losses. So yeah, there was the DAO hack, maybe the parity multisig hack. There was still rare events, and then the DeFi became popular, and now all these hacks seems very small. And also, back then, I don't know, there was like a hack like once a year or whatever. Now you have it on a monthly or weekly basis. with tens of millions. This is probably billions, $3 billion of hacks. So yeah, and that's that's in addition to potential pyramids and value that is lost because the token price goes down. It's simply hacks, and like the reason it didn't really happen before 2020 is that because there are not very many DeFi applications, and now around 2020 DeFi summer began. They held a lot of money. So yeah, billion in funds around 2020. If in 2017 you should just issue an ERC20 and ICO. In 2020 you would launch a DeFi platform, get $1 billion deposits. Like for anonymous teams, very young teams. So yeah, they got hacked. Also, many of the DeFi platforms, because they integrate with other markets, need to be upgraded constantly. Whenever you upgrade a smart contract, whenever you upgrade in general a code, you have more bugs. You have a lot of complex dependencies between the two systems, which even experienced auditors have hard time to track, mostly because you have new DeFi platform which is hot for like 2 weeks, like every month, and it's not very practical to try to follow all of them. And by far, flash loans made most of these hacks possible. So how a typical DeFi hack looks like. And this is something that was considered very complex in 2020. These days it's kind of the standard. So here we have a hack. So this was the original B0X hack. So we had like a transaction that actually involved 1, 2, 3, 4, 5 different DeFi platforms. If you look at the transaction, it's even hard to understand who is the victim here, but so now we know that it was B0X. B0X is a let you trade with leverage, and the attack here was that it was using probably Kyber as a price oracle, but Kyber in turn was using Uniswap as a price reference. So the attacker actually took some flash loan from a platform called DYDX. He short the assets on Compound, which is another lending market, manipulated the price. Then once the price was manipulated, did the leverage trade here in B0X. Then here the price went back to normal, and he also returned his flash loan, but eventually the leverage trade, so the principal of the leverage trade was much higher than what than the collateral he put, because the collateral that they asked him to put was according to a manipulated price feed. So again, this hack with 5 different lending markets. These days it's kind of standard. You heard about it like every week or two. Also, of course, these days, like the good teams understand it. They know these best practices. So it happens mostly on a new exotic markets. But then every once in a while you have new attack vectors which are less standard. And then, of course, industry has to adjust. And hopefully, like to hope that you will not be the first one to be hacked. So what is a flash loan? So flash loan, unlike in traditional finance, so basically because an Ethereum transaction can do multiple stuff in the same transaction. So some protocols allow you to actually take their money, do whatever you want with it, and then just repay the money back. And this is possible only because our Ethereum transaction is built, and eventually they verify that you repay the money, and if they don't repay, they just revert the transaction, and then it's like it's never existed. So now if you see a vulnerability that might even require $100 million to exploit, so now every kid can actually execute it because he doesn't need to have he doesn't need to have money up front. He takes a flash loan, manipulates whatever he needs to manipulate, and repay it all in one transaction with zero risk from the attacker side. So now, so every once in a while new attack vector is discovered, industry adjusted, new best practices, kind of written, auditors track it, investigate it, try to kind of spread the word and the education out there. But eventually, and unfortunately, it happens to many, almost to anyone, even to the best of the best. So here, compound finance, one of the gold standard on how kind of DeFi application should look like. So yeah, just 20 days ago was frozen for almost a month, for almost a week, because of a buggy upgrade in the software. And this is a platform now with $3 billion. In peak, they had probably around $10 billion. So money were only frozen, not lost. But of course, in all these DeFi markets, everything is dynamic. So if someone could not withdraw his money, we might lost it elsewhere. But moreover, there was a concrete risk here for the platform because it's a lending market, and there was some risk that loans could become under-collateralized, which would result in imminent loss eventually for depositors. So that's Compound. Compound is the main competitor of Aave. But yeah, Aave also a few months ago, people discovered that basically there was some bug there, actually not a smart contract bug, but when they deployed the smart contract, they forgot to initialize something there. And it was possible for everyone to kind of freeze all of the user funds there. And there it's again billions, very well-funded team with a long history, long, very positive history. Both Compound and Aave spends millions per year for security audits. Of course, also with very expensive developers, very experienced developers. But yeah, nevertheless, these things happen also for them. And now the last class of bugs is sort of financial bugs, which is just bad risk management. So very famous case there is UST, the Luna incident, where someone, so yeah, I mean, like if you want to give him the benefit of the doubt, kind of build unsolid system for stable coins, gave some assurances, so-called mathematical assurances that the price of some asset will always be $1. Of course, there were obvious flaws there, but if you want to give them the credit, then yeah, maybe he didn't notice these flaws. So right now, Luna, so the founders are basically on the Interpol wanted list. Yeah, but they still tell you, if you want to take the risk, you can still trade them. So this is somewhere, like between obvious Ponzi and maybe, a bug, although, the code work as intended, etc., etc. Something which is more in the gray area. So now you have, so the same way where anyone can start their own token. So now anyone can start their own maybe DeFi platform, here specifically with Ichi. So it was a lending market. But of course, lending market is not only code, it's also about risk parameters. And yeah, so the code again worked perfectly as designed. but the risk parameters there, the financial basis of everything was flawed. And there, people who lend money to others never got it back, and it was something in the order of $100 or $200 million, just because they set these aggressive parameters. So we have simple bugs, we have attack vectors, we have DeFi bugs, financial bugs. And yeah, this is just something to show that, even once we solve everything, maybe there will be better tools for security bugs, maybe more awareness in the community around financial risks. But, like financial attacks or games are happening also in the traditional world. These are all manipulations that were done not in crypto, but in regular, so it's not really stock exchanges, but trading venues. By Morgan Stanley, Berkeley's Capital, etc., etc. So, once all the easy bugs and the code bugs will be cleaned, then probably we will also see more of, kind of pure financial manipulations as well. And with this optimistic note, we'll conclude. And if there are any questions. Yeah. Okay. Yeah. Yeah.
What exactly happened? How can code even
Okay, so if eventually in a ERC20 token, what actually matters is your balance. Okay, so here you transfer the token from this from account to this to account. So it actually lowered the account of the sender, but didn't actually increase the account of the receiver. Right, because so this plus is just, if you add minus here, so minus is just multiplying by -1, so plus is multiplying by +1, which is of course has no effect. So the balance, did it increase? Actually, the balance was even reset, probably. If the value is very small. Sorry? So I'm not sure. So it's not about loss? Or? Yes. So no. So actually, you can also. So for example, I can send you 0 tokens, and it will reset your account. But I can also maybe send to my other account something. Yeah, it wouldn't steal it actually. So it's only to. You can only take, you will not profit from it, but other user will lose. So it cannot be negative because it's unsigned integer, so it can only be, super high. So there are no negative, there are integers, but this is unsigned one. But again, it makes the token completely unusable. Also in the parity hack that I described, no one actually made profit, but people made over $100 million loss. So,
Can you explain how formal verification helps here?
And actually, okay. So formal verification, you can give some specification. For example, here, give standard ERC20 maybe specification saying that, transfer should decrease the balance of the sender and increase the balance of the receiver. So here, it might have catch this bug. You have a lot of re-entrancy. Now a lot of formal verification tools kind of auto-detect re-entrancy and at least warn about it, because sometimes it's, if you write the code correctly, it's okay to have re-entrancy, but you have like static tools that automatically detect whether the contract is potentially vulnerable to re-entry. Yeah.
What are the best tools for formal verification?
Yes, so right now there is an Israeli company, Israeli startup, which is very well reputed, which is called Certora, yeah. But as far as I know, they only give it as a service. I don't know if they have the tool available. Yeah, okay, so I never use it. So yeah, Certora. Some of the big auditing firms also publish kind of, I don't know, yeah, open source tools. So some of them are linters, some of them actually do static analysis. Personally, I mostly use them, it's like a good way to clean your code. It's hard to actually trust them too much to find anything. But the same way it's kind of linter, right? I mean, you want your code to be clean, so clean all the formatting errors, then also clean all the static analysis warnings. So yeah. Yeah, okay, thank you.